on 2.1 through 2.3. So therefore, we're going to 2.4, and y'all know that's the end of the unit. So that means we got to
Hubert, I don't think 2.3 is open. At least I personally didn't see it in the homework assignments.
I was about to say too, 2.3 didn't come up for us.
Somebody should have sent me a email. I'm sorry. I'll check it out. I'm sorry. That's my fault. I wish somebody had sent me an email.
I wasn't sure if it was something you maybe had done on purpose.
No, I meant I'll just explain this. Each lead instructor is supposed to open up all the homework, and some lead instructors don't do that. And the person in charge of 109 didn't do that, so I thought it was open. So let me check it right quick. I'll go ahead and open up both. My bad. Assign, and I'll go ahead and sign 2.4 while I'm at it. And I can tell you right now, we're going to have a due date probably Tuesday, because I'm going to do the test probably Tuesday. So anyway, and I'll look at both tests. I'm going to give you a review test probably and a Unit 1 test, or I might combine it. I don't know. I'd rather give you 2 tests. But anyway, let's go ahead and get started on 2.4. I wish y'all would have told me, but that's okay. You got the weekend to work on both, and you can send me questions on both Tuesday. Everybody with me? Okay.
Yeah, that's fine.
All right, so let's get started on the last section, and that is inequalities. And of course, this is going to be an easier review. Inequalities. And I'm going to go over everything from solving basic inequalities to graphing inequalities. But first, we got to write down the red stuff. The red stuff means the important stuff. And here is the important stuff. I've already shown you this when we went over interval notation and set builder notation, but I'm going to show it to you again. When you have these two guys, you're going to be using open circles. You're going to be using parentheses, and you're going to be using dashed lines. I'll put one more and put a arrowhead there and an arrowhead there, meaning that's a line. Okay, when you're using these two guys, you're going to be using a closed circle. You're going to be using brackets. And you're going to be using a dark, thick line for the graph. You also got to remember that there's called interval notation. Which reads from left to right with parentheses or brackets, depending on what type you have. And then you have set builder notation, which is a little bit fancier way of writing braces X such that, and then whatever your solution is. And I also tell students, this is what we do when I teach solve, graph, whether it be on a number line or a two-dimensional graph, write in interval notation or and set builder notation. Okay, so there's the important stuff. So I want you to make sure you have this written down for this section because I'm not going to, I shouldn't have to come back to this, but especially these two. When I draw a certain type of a circle on a graph or put brackets or braces or on a graph, two-dimensional graph, draw a line like this, I don't need somebody going, well, why did you do that? Well, this is why. Okay. So with that being said, let's go ahead and look at some problems with inequalities. First type, basic equations. 1/2 x plus 3 greater than or equal to 2x minus 7. Now I want to go back and put something else on this page. And I always tell students, always try to keep the variable positive. Okay? I always try to keep the variable positive. Now, you can do that 95% of the time or 99% of the time. There's one problem that you can't do that with, and that's the problem like x plus 2 is less than and greater than 1 and negative 3, or vice versa. That's the problem that you can't, or negative, sorry, negative x squared or negative x plus 2 is what you have to do the rule there. But I'm not going to show that until I actually have to come up on one. I always keep my variable positive. Now that's up to you, but I will guarantee you that on a test, if you keep the variable positive, you will miss less inequalities based on careless mistakes, because people always forget to do the last two steps of dividing by a negative and then flipping the inequality. They always forget that. So I just tell students not to have to worry about it unless you have to. So here I'm going to move, well, first of all, I'm going to multiply through by 2 because I don't like fractions. And I'm going to multiply through by the denominator. That's going to give me a 2 here, a 2 here, 2 here, and a 2 there. 1/2 x plus 3, 2x minus 7. And now we've got x plus 6 greater than or equal to 4x minus 14. This one's the smallest bucket, so I'm going to take it across the river, and that becomes minus 1x. I'm going to take this across the river, and it becomes positive 14. 3x is less than or equal to 20. Divide by 3, divide by 3. X is less than or equal to 20 over 3. So there is our solution set. Now we got to put it in set builder notation and interval notation, and or graph it first. Sorry, got to graph it. So I'm going to go to my handy dandy graph. And this is a number line because it's not a two-dimensional graph. So I'm going to graph. This is negative infinity. That's positive infinity. And that's 0. And 20/3. 20/3 is what? 7 and 7. Let's see, 6 and 2/3. So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So x is less than or equal to 20 over 3. So I'm going to put me in a closed circle at 6 2/3. And somebody tell me what numbers are less than 6 2/3. That means I want y'all to say something. That means I want y'all to interact. Come on, Mr. Abdallah, you can do it. Oh God, he just went away.
Okay. Repeat the question.
What numbers are less than 6 2/3?
-7. Oh, like 6 2/3.
To the left or to the right?
2/3. Anything to the left.
Anything to the left. Thank you. So I'm going to shade anything to the left, which includes negative infinity. So with interval notation, I read from left to right, unless you're from the Middle East, Masalama. That's the word they taught us in military. Masalama means walk in peace or go in peace, doesn't it? Negative infinity. Say again.
Nothing.
Negative infinity to 20/3. And set builder notation is x such that x is less than or equal to 20/3. And that's how you do an inequality. Now, I will tell you, there's a lot of people that go through algebra 101, 102, algebra 1, algebra 2, that have never understood an inequality. And if you haven't, if you still don't, make sure you speak up. Everybody feel good about themselves? All right, let's try nerding. Two x plus 6, and make that a 3 greater than or equal to x minus 2. All right, go to it. I'm going to let y'all do this one. Oh. Mr. Abdallah, are you there?
I am here.
What origin is Abdallah?
I guess my parents are from Jordan. Yeah, so they were born in Jordan. So I guess it probably
I was curious.
down there, huh?
I spent about close to a year over there in the Middle East. That's why I was asking.
Yeah, I figured.
I always ask because I'd like to know if somebody is from Saudi Arabia or not, or Kuwait.
Yeah, I've got some family in Saudi Arabia, but I've actually never been.
Well, that's an interesting place. That's an interesting place in the world. That whole area is interesting. A lot of history and a lot of turmoil, but looks like things are turning around a little bit.
Yeah, I hadn't heard anything bad lately, so.
Yep, and there's actually peace talks, so that's a good thing.
Yeah.
So, but it is, I found it to be one of the most interesting things that I've ever experienced, is being in that part of the world. I'm not going to say I enjoyed living in the desert for about 8 months, but I will say it was the most interesting. I tell you, if you ever feel like if you ever feel like you're privileged, live in the desert for about just 3 months. I guarantee you'll appreciate where you live, no matter where you live, when you live in the desert for 3 months. Is there much desert in Jordan?
Yeah, it's pretty. I guess it just depends on where you are, but it's still a desert.
Yeah.
You know, yeah.
Pretty much the Middle East is, yeah.
It snows and stuff.
Yeah. Well, actually, I was in the desert from, well, pretty much from December to the next September or October, and I'm gonna tell you something. When that stuff gets wet, it turns into nothing but hard clay.
Yeah.
And you can hardly walk through it. It's amazing what that sand will turn into. And cold at night, oh my Lord, you'd have to sleep in your clothes in a sleeping bag just to be able to sleep.
Yeah.
I mean, it's just amazing. It's amazing what the desert does as far as weather.
Gets hot and gets really cold.
Exactly. All right, let's do this one. So distribute, and that's going to give us 6x plus 18 greater than or equal to x minus 2. And that brown is going in the trash can. Okay. So this is my little bucket. Take it across the river. Take this one across the river. And that's going to give me 5x is greater than negative 20. Divide by 5. Divide by 5. X is greater than negative 4. Number line. Negative infinity. Positive infinity. 0. 4. Negative 4. Oops. Drop my inequality. There we go. And that's going to be a closed circle. And what numbers are greater than negative 4? To the right or to the left?
I think to the right.
To the right. Thank you, Mr. Melnick. And that includes positive infinity. So set builder notation is negative 4. I'm sorry, interval notation is from negative 4 to infinity. And set builder notation is x such that x is greater than or equal to negative 4. Now, you should be able to do those type problems. And hopefully, those are problems that you've seen in the past. Yes or no? Okay, well, let's move on to problems with graphing. So the problems in graphing are going to look something like this. Somebody did say something. I have to switch. That's the only thing I don't like about this. I have to switch between to see what. Why did I live there? Is that why you, was that directed toward me?
I think it was.
Okay. I was in the military. There was a war over there. That's when I was over there. So, okay. Let's do, how about 2x plus 3y is greater than or equal to 6, and x or 4x minus 2y is greater than 8. Okay, this is a system of equations, or well, no, it's a system of inequalities. So I want you, and this is on a piece of graph paper. I don't have one with me. So that means I need to, I'm going to have to, while you're working on it, I'm going to print me out one. That'll take a long time because it's a lot of work and a lot of, just a lot of stuff involved. It takes forever to print out a piece of graph paper. It's just awful. You have to type it in, graph paper online, and then you have to hit enter, and then you have to hit images, and it's just awful. Save image as online graph paper. There, thumbnail graph. And pull that up. Oh, great. Really? It won't pull up? Open link in new tab. How about that? Oh, it's going to open up that whole link. Let me try that one. Save image, thumbnail graph. Let me open a word processor and do it that way. I'm talking to myself, just ignore me. Insert pictures, downloads. Why won't that fit the page? Well, that's going to suck. Hold on. Let me insert pictures. Oh, well. Fix this dadgum design. Where is the freaking layout? Margins. Narrow. Thank you. Well, I guess that'll work. And print. It's really too big and it's going to be like huge. But hold on a second. No, go get that. Okay. Well, this is super huge, and it's probably not going to work, but we'll try it anyway. So I'm going to take my handy dandy straight edge. And the reason I have to use a piece of graph paper is because we're going to be graphing, and I want it to be accurate. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4, -5, -6, -7, -8. 1, 2, 3, 4, 5, 6, 7, and 8. And -1, -2, -3, -4, -5, -6, -7, and -8. All right, I'm trying to make the best of it. All right, so our problem, I'll write it down again, is 2x plus 3y greater than or equal to 6. And we'll do that in brown and do the other in blue. 4x minus 2y greater than 8. Okay, we'll do the blue one first. So I'm going to plug in 0 for x. That's my y-intercept. And 0 for y. That's my x-intercept. If I plug in 0 for x, that's going to give me a -4. If I plug in 0 for y, that's going to give me a +2. I'm using the intercept method, which I've shown y'all before. Okay, over here, 0 for x, 0 for y. 0 for x, I get 2. 0 for y, I get 3. So let's plot my brown line. 0, 2 is your y-intercept. X-intercept is 3, 0. And I draw a real solid solid line that's a little bit thicker than normal, because it means that you have a equality with an inequality. Now I graph. Well, before I graph, I got to check to see which one works. Now, plug and chug. If it's true, you shade. If it's not true, you flip and shade. So pick a point. Now, which point do you think I'm going to pick? Does anybody have any idea which point I'm going to pick? Somebody's supposed to guess. That means say something. That means interact with the teacher. So nobody has a clue what point I'm going to pick. Is anybody there?
Yeah, I'm just having a hard time keeping up.
Okay. What's the matter, Mr. Melnick?
I was just writing everything down, and I didn't really.
What? I'm sorry, I didn't understand.
I was writing everything down.
Okay. I'm going to pick 0, 0. Does anybody know why I'm going to pick 0, 0? Because it's the easiest math to do. Yes, that's right. 0, 0. Plug in 0. 0 plus 0 is 0. Is 0 greater than 6?
No.
No. So I flip to the other side. There's 0, 0. It's on this side of your line. So I flip and I shade this side. So all my X and Y's that will work in this equation are on this side. So let's pick 3 and 3. Let's pick this point. 2 times 3 is what? 6. 3 times 2 or 3 times 3 is 9. So that's 6 plus 9. Is 15 greater than or equal to 6? Yes. So that one works. All these points will work, including this point right here at 0 and 2. That will work because it's equal to. Okay, so let's do the blue line. The blue line is 0, -4, and 2 and 0. Good, I was hoping I did this to where they would intersect at a nice place. And I draw this line. What kind of line is it? It's a dashed line, Hubert. That's right, class. Again, I'm going to pick 0, 0 because it's easy math. Is 0 greater than 8? No. So I flip to the other side and I shade this side. Now somebody tell me where the two shades, where they overlap. They overlap right over here. So I'm going to shade that in, and that's going to be called the feasibility region.
New Facebook comment.
That's called the feasibility region. Tell me what the feasibility region contains. The solutions to not just one, but what?
Both.
Both. Thank you. Good gracious, I appreciate that one syllable interaction. Thank you. Both. So that's going to be called the feasibility region. And the feasibility region is going to be from this point on to the right. So what's that point? Well, we got to find out that point. We got to set them equal to each other and find that intersection point. Because we can't see here, we can't determine that. So we got to find that X. So we got to use a system of elimination or substitution. Excuse me. Or we can just go to the handy dandy calculator and do it. But we're going to have to solve both for Y if we do that. Or we could just use the, use the elimination method. Or we could use substitution. But substitution is going to be a pain, so we just might want to just usually it falls on a nice spot Here we'll say x is greater than 2.3. I would say x is greater than 2.33. So the feasibility region is x is greater than. Now we can't use equal to because this line is dashed. So greater than 2.33, and that's approximate. I don't think they're going to ask you that, but if they do, it'll be an easier question than the one I just gave you, because they'll make it fall on a actual corner like this one right here. They make it fall there where you can actually say x is greater than 2. Okay. So let's see if I can find one in your homework that we actually have to do this. I think they do this in your homework. Any questions on this one?
Just so I can clarify.
Yes.
Can you go back to it real quick, if you don't mind?
Yeah. What was your question?
So, okay, so for like 2x plus 3y, like greater than or equal to 6, right?
Uh-huh.
When you have the 0, 2 and the 3, 0, that 0, 2, right? Like that first one, it's always going to go on my, like the y-axis.
Yeah, that's all. When you plug in, and I went over this in the review, or whenever we did graphing, I can't remember. But whenever you plug in 0 for x, that's going to be your y-intercept.
Okay.
And remember, that's something you should remember from Algebra 1 and Algebra 2. When you plug in 0 for y, that's always going to give you the x-intercept.
All right, cool. I understand that now. Okay, I see.
Fine. That's what this is for you to kind of, review a little bit, because this is Algebra 2 material. Okay. So let's look at your homework and see if there's something in there. And these will be your ending questions, the ones that end. So let's go to main menu, assignments, and 2.4. Let's see if they actually give you. They may not. I just looked through the book before class to show you. Okay. Let me see if they ask you to graph any. Oh, that ain't what I'm talking about. That ain't what I'm talking about. That ain't what I'm talking about. Nope, they don't. So I don't. You ain't got to worry about it. So let's go to a question that I would put on the test. Okay, that's one, but you really don't have to do that one because, that one's okay. We'll do that one in just a minute. That's one. That's one I would give you on a test. So it says solve the inequality both algebraically and graphically. So the inequality I just showed you right here, that's good for your information, but I don't think you're going to see any of that on the test. But that's good for your information. I thought I saw one in the book. I may be crazy, but maybe the person that designed this course on MyLabs Plus, maybe they didn't put any of those on there because it's in your book. All right, so let's go ahead and look at this one. This one is, I'll write it on my sheet, 2.8x minus 1.2 greater than or equal to 5 minus 1.2x. Does anybody have any clue on what I'm going to do before I even start this problem? Anybody? I'm going to clear the what? I'm going to clear the decimals, Hubert. That's right, class. I don't want to work with decimals because then I'd have to rely on what? Little idiot box. So I'm going to multiply by 10, and that's going to move this one. and move this one, and move this one, and move this one. And that will give me 28x minus 12 is greater than or equal to 50 minus 12x. This one's the smallest bucket, so I'm going to move it across the river. That becomes a 12x. This one is going across the river. That's going to become 12x, or 12. And 28 plus 12 is 40. And 50 plus 12 is 62. Divide by 40, divide by 40. X is greater than or equal to, well, that'd be what, 31 over 20? And that's going to be greater than, let's see, 20 will go in there one time, leave what, 9 over 20? Let's see, 20, no, 11 over 20. 11 over 20, that's going to be something like, let's see, divide by 10. If I divide by 10 here, I'm thinking divide by 2 over 2, that's going to give me 5.5 over 10, which is 0.55. I get 1.55. Somebody check my math. $31 over 20. Somebody type that in the calculator for me, please.
Yeah, you're right.
Okay, so now I've got my answer. Now I'm going to graph it. 0, negative infinity, positive infinity, 1.55, and negative 1.55. And I'm going to put an a closed circle at 1.55. And somebody tell me what numbers are greater than 1.55. To the right, Hubert. That's right, class, and that includes positive infinity. So interval notation is from 1.55 to infinity. And set builder notation is x such that x is greater than or equal to 1.55. And who has questions? So either y'all are just dead today or I'm covering this stuff exceptionally well. I don't know which one it is. And nobody's going to say anything. Appreciate it. Appreciate the interaction. It's always nice to have people interact with you during class. Y'all settle down, please. So I get, let's see, it says type an inequality. Doesn't say, so I'm going to use interval notation. It's probably not going to like it, but I don't care. 1.55, comma, infinity, close parentheses. All right, and let me just do an inequality. X is greater than or equal to 1.55. If you don't like this, then I'm going to type in a fraction. There it goes. Interval notation is brackets 1.55, comma, infinity, close parentheses. And which one is it? We said it looks like the 1.55 and to the left. So that means that's not it. That's not it. That's not it. That's not it. We know it has to be a closed circle or a bracket. So let's just do some deduction here. Let's say that you don't have a clue. There we go. And I'm going to take my handy dandy marker and red marker. And this one's not it because it's pointing to the left. This one's not it because it's pointing to the left. This one's not it because it's pointing to the left. And this one's not it because it's pointing to the left. Now let's take out the ones that have parentheses because you don't need parentheses, you need bracket. So we've narrowed it down from 8 to 3. So which one is it? Well, 1.55, that's a negative. That ain't it. So it's either this one or it's this one. So you narrowed it down from 8 to 2. Is that what you're supposed to do with these problems? Hell to the yeah. So it's not this one because that's 0.75. So it has to be H as in hotel. And you should feel good about yourself. That's a good test question. I like that one. Let's do a nerd. There has to be one with fractions. There we go. There's one with fractions. Let's see if we can find. Man, I guess that's going to be hot. I'll tell you what. Let's go to chapter contents. Let's find some good problems. I might make a new homework. Let's see. Where's chapter contents? E-text contents. Chapter, what is this? 2, 4, and study plan. I bet there'll be a lot of study plan questions. Okay. Where is it? There we go. This is how many homework questions you should have. All right. So let's see what they got. Let me see if I can find one that I like. Ooh, that's a good one. All right, try that one. Try that one. I'll be writing it down while you're working on it.
Priority 1 message coming
golly
in on
molly.
secure channel.
Okay, so 5 times x minus 6 over 2 greater than or equal to 2x over 7 minus 20. And what am I going to do first before I even start? That's meant towards y'all to answer.
So multiply 5.
I'm going to clear the fractions by multiplying through by 14. I'm going to put a 14 here, 14 here, 14 here. Five times x minus 6 over 2.
How do you know to use 14?
These two together, 7 won't go in. You got to. I'll show you how. You go over here and you do 2 and 7, and then you put the prime numbers on top of it. 2 times, or 2, 3, 5, 7, 11, and sometimes 13. And you divide until you get ones. So 2 won't go into 7, but I'll just go ahead and get a 1 there. That'll give me a 1 and a 7. And then 7, 1, and 1. When you get the 2 ones, you've got your common denominator, which is 14. That's how you get it. You don't just multiply them together. Does that help?
A lot more. Yeah, definitely a lot more. Yeah.
Oh, yeah, because if you have 2 and, like if you got something like 8 and 24, if you had 8 and 24, a lot of people just multiply them. Well, that's not the way you do it. 2, 3, 5, 7, 11, sometimes 13. 2 will be a 4 and a 12. 2 will be a 2 and a 6. 2 will be a 1 and a 3. And 3 will be a 1 and a 1. 24 is your common denominator. A lot of people would say 8 times 24 and get 184 or 182 or something, or 192. And that's not that, you don't multiply them together. That's how you find the common denominator. A lot of people don't even know about this because they never were taught. That's why they can't do fractions. All right. So anyway, 2x divided by 7. Just a quick question, Mr. Melnick. Have you ever seen that before?
I don't really recall it.
Yeah.
To be honest.
A lot of people have never seen it. Minus 20 over 1. Okay, so 14 divided by 2 is 7. The 14 and the 7 cancels, that's 4x. And 14 times 20 is 280. All you got to do is 14 times 2 and add a 0. I have had people type this in their calculator. Okay, don't say anything. If you just type 14 times 20 in your calculator, don't say anything. But I have had people, when I was in class and I was walking around, I'd say, okay, now multiply 14 by 20. And I actually saw students take their calculator and multiply 14 times 20. When they know 14 times 2 is 28 and you just add a 0. That's called dependency on a calculator. 35 times x minus 6 is greater than 4x minus 280. 35x minus, well, 35, that's going to be a 30, 330. Somebody check my math. Okay, somebody's supposed to check it for me. 35 times 6. Okay, I'm starting to wonder if y'all are cognitive.
10.
What'd you get?
210.
Okay, well then I messed up.
35 times 6, you said?
35 times 6, you got 310?
I got 210.
Yeah, 6 times 3 is not 30, Hubert. Stupid. Sorry, I talk to myself sometimes. 6 times 5 is 30. That'd be a 0. Bring you 3. 6 times 3 is 18, not 30. Oh, sometimes my brain doesn't work the way I want it to. Okay, so 35. So this is my little bucket. Bring it across the river. This is my other one negative. Bring it across the river. It becomes positive 210. So 31x is greater than, well, you owe $280 You have $210. This is my life. You have 280. You owe 280. You have 210. You still owe 70. So X is greater than or equal to negative 70 over 31. Now we're going to finish it by filling everything out. Graph it. So X is greater than or equal to negative 70 over 31, which 2 would be 68, or I'm sorry, 62. So 2 and 8 over 31. Let's see, I'm thinking out loud. 62, I think that's right. So graph, this is positive infinity. This is negative infinity. I actually had a student tell me that they didn't know that this arrowhead was called negative infinity and this arrowhead was called positive infinity. That blew my mind. 0, 3, and negative 3. So I get a solid 831. Let's see, 8. I'm trying to think. Let's see. 8 over 24 would be a third. 8. I'm thinking 8. 30 seconds would be a fourth. So 3. That's about 2.25. 2.25 would be right. Let's see, 1, 2, 2.25 would be right there. And what numbers are greater than negative 2.25? Well, that would be everything to the right. And that includes positive infinity. So X such that X is greater than or equal to negative 70 over 31, or negative 2.2 and 8 over 31, or somebody, is it 2.25? What is it? What is it precisely? Negative 2 point what? I'm sorry, what?
0.258.
0.258. So I was right near it. Okay, so that would be set builder notation. Okay, depending on what they want, the directions may say a fraction. The directions may say a mixed number, which I doubt, or they may say a decimal. That's probably either a decimal or a fraction is probably what it wants. And interval notation would be from negative 70 over 31, or negative 2 and 8 over 31, or negative 2.258, comma, infinity, and close it. So now we just need to read the directions and see what they want, a decimal or a fraction, because I doubt very seriously they want a mixed number. Mixed numbers are only used with units of measurement. So let's see what they got in their handy dandy question. The solution as an inequality, and they use integers or fractions. Let's try the decimal and see if it likes it. Let's do X is greater than or equal to negative 2.258. Okay, then let's try negative 70 over 31. There we go. They wanted a fraction. Interval notation. is bracket negative 70 divided by 31, comma, infinity with a parenthesis. Okay, let's do some more deduction. We know it's a solid circle, and we know it's to the right. Delete this. Oops. A solid circle and to the right. So let's take off. Oh, I'm sorry. A bracket and to the right. So let's take that off. Let's take that off. Take that off. Take that off. Take that off. Now we got it down to 3. Okay, I'm going to have to close this up. Okay, this is a negative. 0, negative, so that ain't right. Oh, wait, it is. We need a negative. This is a positive. That ain't right. So now it's down between C as in Charlie and D as in Delta. So all you got to do now is find the right location. It should be close to -3. I guess this is the one it's going to be because this one ain't even got a -3 on it. So it's not that one. Should be Delta. Let's see if we feel good about ourselves. And we do. So these problems aren't that difficult. Question. Nobody's going to say anything.
Yeah, actually, I do have a question. So if I didn't multiply fraction out, like honestly, is it still possible to get the right answer?
Oh yeah.
Okay.
That's more.
It's just a lot
work.
harder.
It's more work for you that you need to do, but that's up to you. You should. Did you get the same answer?
No, I didn't.
Okay, well let's do it the way you.
No, actually, I don't want to. I think your way is just easier.
Okay. Wait, you want to do another one like this?
Nah, I mean, we can. I don't care.
Does anybody want to do another one? Raise your hand if you want to do another one like this. Okay, the democracy rules. Everybody says they're okay. So I think, to me, that's probably that one and this one is probably going to be the hardest ones I give you. Let me see. Graph by the intersection method. I showed you how to do that. Just solve and graph using a dashed line because that's a dashed line. So we could do that one. Let's see, 6x. Graph 6x plus 1 and y is equal to using the graphing tool. I'm not going to test you on that. There's another one. There's a test question right there. That's not. Remember, these are not on your homework. Let's do this one because I haven't done one like this. This one says 16 less than or equal to 8x minus 27 less than or equal to 29. So get rid of the 8x. I'm sorry, that's not right. Forget that I just said that. Get rid of the 27. So I'm going to add 27 here and add 27 here. And that's going to give me 8x in the middle. And 16 plus 27 is 40, what, 43? And 29 plus 27 is 56. Divide by 8. Divide by 8. Divide by 8. 43 over 8 less than x less than, isn't this 6? Let's see, 7. 7 times 8.
Yeah, 7.
7.
Yeah, I'm terrible with my 8 multiplication tables. Okay, and that should be your answer. Unless I added 16 and 27 wrong. Now, this brings up a good problem. What if that's a negative 8x? Or what if it's a negative x? That's the problem that you can't get away from, and you have to divide through by negative. So 16 less than negative x plus 2. Okay, I'm just changing it a little bit. This is the problem that you can't make the variable positive. Okay, you can, but it's more work. Okay, so this is when I tell you that you have to, it's easier for you just to do the old rule. If you divide or multiply by a negative, you have to flip the inequalities. Okay, if you multiply or divide through by a negative, you have to flip the inequalities. So we got to get rid of the 2 first. So minus 2, minus 2, minus 2. And that gives us 16 minus 2 is 14. And 27. Here is where you divide by -1. And when you do that, you have to flip the inequalities. So that's a -14. Flip it. X. Flip it. -27. And that is why I tell you, try to keep the variable positive. Here you can't. The reason you had to flip the inequalities because you divided through by negative. And this is the only question this is the only type problem that you have to do this. There's no way around it. Graph it. This is negative infinity. I'm sorry, positive infinity. This is negative infinity. This is 0. This is -14. This is -27. And I'm going to put a closed circle on -14. And I'm going to put a closed circle on -27. What numbers are between -14 and -27? Well, I shouldn't have to tell you that because this says between. So it's these numbers right here. So interval notation would be -27 to -14. And then interval notation would be x such that x is between -14 and -27. Now make sure you make a note of this because this right here, this right there is what's going to get you on the test. This one or the one we just did with -8 or whatever. This one right here. That's the two that are a little bit different. So I've shown you basically about 5 problems that you could have on the test from 2.4. But you're going to send questions after the weekend. So, okay, so that takes care of that. I'm going to shut off the presentation. And I'm going to shut off the recording. And